Hey guys, I'm Rock, who created Rick project. This video will show you how to quickly get started with Rick, which is an amazing Golang HTTP library. Let's create a Golang project at first. Add Rick to dependencies with GoGet. Then create a main file and write the main function, enabling the dev mode of Rick so that we can debug HTTP. Then let's just test with a specific URL. Then let's run our code to see what will happen. In the dev mode, we can see some debug logs are printed, and the complete request and response content are dumped, so it's very easy to debug API. From the header format of the dump, we can see that this is the HTTP2 protocol. Rick will use HTTP2 by default if server supported. Of course, you can also force to use HTTP1 or HTTP2 if you want. The client and request is the two core objects, and every request is sent by a client, and both of them can sit by the changeable methods. But here we didn't create any client and request explicitly, just call some global methods to set client and send request. Behind this is actually because Rick wraps all methods of client and request with global methods, so that you don't need creating any client and request explicitly when testing. Just treat the package name as client and request to call the methods. The former is called the same method of the default client, and the latter is create a request using the default client and call the same methods of request. But we suggest to create client explicitly in production. Let's change our code, call C to create a new client, and call R of client to create a new request. And then send the request to the same URL as before. Let's run it again. Same result as before. The reason why the shorthand C and R are used to create client and request respectively is because these two are very high frequency operations, and the shorthand can shorten the code and improve readability. Of course, method alias such as new client and new request are also provided. Let's modify our code, change to post, and call the set body to set the request body. Let's run it and see what happened. You can see that this is the post request with request body, and method not allowed is returned. Let's modify the URL and try it again. And this time 200 says status code is returned, which means that the request is a success. And the response body is the JSON format. Let's copy the JSON and create a struct with the same structure. My name is as response body. Then call set result, indicating that it is expected that the API will return the format of this struct. And when this request is successful, it will automatically unmarshal the data into the struct. Here we just simply panic if error happens. If there is no error, we still need to judge whether the API response is successful. Normally, response is successful when the status code is between 200 and 299. If response is successful and the set result is called, that must mean that response body has been automatically marshaled into the structure. So we can get the field what we need from the struct. Here we just print the data field and cancel the dev mode to avoid printing too much information. Run it again. Here we can see that the only data field is outputted. Let's customize some other request settings. Change the client setting at first to enable dump for all requests without response content, because we only care about the request content. Let's set some query param for request. Param1 with value 1 and param2 with value 2, and run it again. You can see the param is appended to the URL. And let's enable the debug log to see the complete URL. Here you can see the complete URL. Next, let's set the header with header 1 and header 2 and run it again. Those headers are added. And next, let's set the path param, which is the REST style API. Take GitHub API for example. Uh, there is a variable in the path called the username. Let's pass the username variable to the setPathParam function and run it again. We can see the variable in the URL is being replaced. Some request settings can also be set on the client level, meaning common settings are set for all requests. Let's set the common header and a common query param with header 1 and param 1 and enable dump without body. Let's run it. We can see that both the query param and header is set on the request. The settings can be overridden at the client level. Let's override the query param1 with the value 1, and also we can override the header 1 with value 1. And run it again. We can see both query param and the header are overridden with the value 1. Let's see what we should do when the API returns error. For example, let's to query some unexisted user with the GitHub API. You can enable dump at the request level, which means that it will not print it out by default. You can get the dump content only if you want. If the response returns an error, which status code is bigger than 400, then let's see what the response is returned. Let's just print the dump content, which help us troubleshoot problems. And indeed, the API returns an error with the 404 status code. Let's copy the error message and create a struct with the same structure. Let's call it error message. Let's call setArrow, indicating that we expect the API to automatically marshal the error message into the struct when it returns an error. And then we can just extract the field what we need. Let's just print the message field. Great, it works. And you can also enable trees to analyze the performance. Let's get the trace information and print it out. We can see detailed time-consuming information. You can also call blame to record the main factors that lead to the high time consumption. There are many more powerful functions of rig. This is just the tip of the iceberg. For more details, please refer to the official documentation on the GitHub.